pattern of this 2 by 2 matrix is A sub 1, A sub 2, B sub 1, and B sub 2. To find the determinant of a 2 by 2 matrix, we will use the formula B is equal to A sub 1 times B sub 2 minus A sub 2 times B sub 1. In this 2 by 2 matrix, the set of elements is 5, 2, 3, and negative 7. To find the determinant of it, we will use the formula that is mentioned earlier. So, B is equal to 5 times negative 7 minus 2 times 3 equals negative 35 minus 6. So, we have negative 41. So, the determinant of this 2 by 2 matrix is negative 41.
In determining the error of 2 by 2 matrix, first, interchange the position of the row or column. So we have the set of matrix 2, negative 7, 5, and 3. Then, follow the procedure in finding the determinant of the given 2 by 2 matrix. So we have here 2 times 3 minus 5 times negative 7 is equal to 6 minus negative 35. So we have 41 as the error.
I will be discussing the solution to find the determinant of a 3 by 3 matrix. In 3 by 3 matrix, we have A sub 1, A sub 2, A sub 3, A sub 1, A sub 2, A sub 3, C sub 1, C sub 2, and C sub 3. Where the vertical array of numbers is called the column, and the horizontal array of numbers is called the row. In finding the determinant of a 3 by 3 matrix, we can use either the column, the row, or crisscross. But in any ways, we must always consider the orders of signs in each element within the 3 by 3 matrix, which can be presented as positive, negative, positive, negative, positive, negative, and so on and so forth. Since we are to use the column to find the determinant, we have the formula D is equals to A sub 1 times B sub 2 times C sub 3 minus B sub 2 times B sub 3 minus A sub 2 times B sub 1 times C sub 3 minus C sub 1 times B sub 3 plus A sub 3 times B sub 1 times C sub 2 minus C sub 1 times B sub 2. For example, we have a given 3, 2, 1, 9, 1, 1, 6, negative 1, and 1. Now, get the element of column, which is 3, 2, 1. Using the given formula, we will have D is equals to 3 times 1 times 1 minus negative 1 times 1 minus 2 times 9 times 1 minus 1 times 6 plus 1, 9 times negative 1 minus 6 times 1, which will give us 3 times 1 plus 1 minus 2 times 9 minus 6 plus 1 times negative 9 minus 6, which is equals to 3 times 2 minus 2 times 3 plus 1 times negative 15. 6 minus 6 minus 15 is equals to the determinant, which is equals to negative 15.
In getting the determinant of a 3 by 3 matrix using row determinant, we first get the elements of the first row. Be sure to multiply it to the corresponding sign for that reference element. Positive 3, negative 9, positive 6. Then, get its cofactors by crossing out the other elements of the row and the column. In the first element, we can draw broken lines in the first row and first column, leaving us 1, negative 1, 1, and 1.
In the second element, cross out the first row and the second column, leaving us 2, -1, 1, and 1. In the last element, cross out the first row and the third column, leaving us 2, 1, 1, and 1. Then, perform the 2 by 2 matrix discussed earlier. 1 times 1 equals 1, minus 1 times -1 equals +1. Then, 2 times 1 equals 2, minus 1 times -1 equals +1. And the last, 2 times 1 equals 2, minus 2 times 1 equals -1. Then, multiply it with its reference element. 3, -9, and +6. We then now simplify it. 3 times 1 plus 1 equals 2, minus 9 times 2 plus 1 equals 3, plus 6 times 2 minus 1 equals 1. 3 times 2 equals 6, minus 9 times 3 equals 27, and 6 times 1 equals 6. Giving us the determinant of -15. Determinant.
In finding the determinant using diagonal expansion, first we must complete the first and second column. The first set of matrix. And copy the first and second column. Then, we will multiply it diagonally. Times 1 plus 9 times -1 times 1 plus 6 times 2 times 1. After we multiply all the numbers in the left side, we will now multiply the set of numbers diagonally in the right side. 9 times 2 times 1 minus 3 times 1 times 1 minus 6 times 1 times 1. After multiplying all the numbers, we'll now simplify it. 3 times 1 equals 3 plus 9 times -1 times 1 equals -9 plus 6 times 2 times 1 equals +12 minus 9 times 2 times 1 equals 18 minus 3 times 1 times 1 equals 3 minus 6 times 1 times 1 equals 6. Then, we will now simplify it and get the determinant of the diagonal expansion. 3 plus negative 9 plus 12 minus 18 minus 6 equals negative 15. And the determinant we got using the diagonal expansion is negative 15.
Finding the error of a 3 by 3 matrix using the row determinant. Our set of matrix is 3, 9, 6, 2, 1, negative 1, 1, 1, 1. The interchanging process in determining the error, we have the original pattern, A sub 1, A sub 2, A sub 3, B sub 1, B sub 2, B sub 3, C sub 1, C sub 2, and C sub 3. The first interchange process is we are going to interchange the second row and the third row. And we have the result of A sub 1, A sub 3, A sub 2, B sub 1, B sub 3, B sub 2, C sub 1, C sub 3, and C sub 2. Another process is by interchanging the first row and the third row. And we have the result of A sub 3, B sub 3, and C sub 3, A sub 2, B sub 2, C sub 2, A sub 1, B sub 1, and C sub 3. And the third pattern is interchanging the first and the second row. And we have the result of A sub 2, B sub 2, C sub 2, A sub 1, B sub 1, C sub 1, A sub 3, B sub 3, and C sub 3. Using the original pattern using the pattern that we made, we are going to apply the original set of matrix, which is, the result is 3, 9, 6, 1, 1, 1, 2, 1, negative 1. Another set of matrix using this pattern is 1, 1, 1, 2, 1, negative 1, 3, 9, 6. And the last set of matrix using the third pattern is 2, 1, negative 1, 3, 9, 6, 1, 1, 1. Since our aim is to use the row determinant, we have the first element or the first set. Using the principal minor, 3, 9, 6. 3 times 1 times negative 1, we have negative 1, minus 1 times 1, we have positive 1. Another principal minor is positive 9. Minus positive 9 times 1 times negative 1 minus 2 plus another principal minor, 6 times 1 minus 2. In simplifying, we must first simplify the inside the parenthesis. So 3 times negative 1 minus negative 1 is negative 2 minus 9. Negative 1 minus negative 2, we have negative 3 plus 6 times negative 1. So 3 times negative 2, we have negative 6. Negative 9 minus positive 3, we have positive 27, and 6 times negative 1, we have 6. So our error for the first pattern is positive 15. In our second pattern, we have the set of matrix 1, 1, 1, 2, 1, negative 1, 3, 9, 6. Our principal minor are 1, 1, 1. 1 times 6 plus 9 minus 1 times 12 plus 3 plus 1 times positive 18 minus 3. Since we are going to simplify inside the parenthesis, we have 1, 6 plus 9 is positive 15, minus 1, 12 plus 3, we have positive 15, plus 1, 8 minus 3, we have positive 15. So 1 times positive 15, we have 15. Negative 1 times positive 15, we have negative 15. Plus 1 times 15, we have positive 15. Simply cancel this, so we have the second pattern, the error is positive 15. And our last pattern in the finding the error of a 3 by 3 matrix using row determinant, our principal minor is 2, 1, and negative 1. 2 times 9 minus 6 minus 1 times 3 minus 6 minus 1 times 3 minus 9. Since we are going to simplify inside the parentheses, 2 times 9 minus 6, we have 3 minus 1. 3 minus 6, we have negative 3. Negative 1, 3 minus 9, we have negative 6. Multiply 2 minus 3, we have positive 6. Negative 1 times negative 3, we have positive 3. And negative 1 times negative 6, we have positive 6. Simply add 3 plus 3 plus 6, we have the last error is positive 15.
There are another way of finding the error of 3 by 3 matrix using column determinant. This given matrix is 3, 9, 6, 2, 1, negative 1, 1, 1, and 1. As the speaker said earlier, he interchanged this given matrix into another position that we can find the error. So let's solve it. First set of matrix that he interchanged is 3, 9, 6, 1, 1, and 1, 2, 1, and negative 1. Now, let's find the principal factors of column determinant. Now, let's multiply 1 times negative 1 is negative 1 minus 1 times 1 is 1. 9 times negative 1 is negative 9 minus 1 times 6 is 6. 9 times 1 is 9. 1 times 6 is 6. Now, let's subtract it. Negative 1 minus 1 is negative 2. Negative 9 minus 6 is negative 15. 9 minus 6 is 3. After getting the difference of the given elements, now let's multiply it from the principal factors. 3 times negative 2 is negative 6. Negative 1 times negative 15 is positive 15. Positive 2 times 3 is positive 6. Now, when we add this product, we can find the error of 15. In the second set of interchanging this set of matrix, we have 1, 1, and 1, 2, 1, and negative 1, 3, 9, 6. We copy the principal factors of column. Now, let's multiply it. 1 times 6 is 6. 9 times 1 is 9. 6. 1 times 6 is 6. Times 1 times 9 is 9. 1 times negative 1 is 1. Minus 1 times 1 is 1. Now, let's simplify it. 6 plus 9 is 15. 6 minus 9 is negative 3. Negative 1 minus 1 is negative 2. Now, let's multiply the principal factors to the elements. 1 times 15 is 15. Negative 2 times negative 3 is positive 6. Positive 3 times negative 2 is negative 6. Now, let's cross out this 6 minus 6 because the answer to this is 0. So the left answer is 15. So the second error is 15. The third set of matrix that has been interchanged is 2, 1, and negative 1, 3, 9, and 6, 1, 1, and 1. Now let's get the principal column factors. 9 times 1 is 9. 1 times 6 is 6. 1 times 1 is 1. 1 times negative 1 is 1. Positive 1. Plus 6 times 9, 1 times 6 is 6. 1 times 9 is positive 9. Now, let's subtract it.
Now I'm going to discuss the other process on finding the error of a 3 by 3 matrix using diagonal expansion. We have here the second matrix, which is 3, 9, 6, 2, 1, negative 1, 1, 1, and 1. On solving diagonal expansion, first we must interchange the rows and put the first two columns on the right side. Then multiply the first diagonal. 1 times 1 times 6 is equals to 6. 1 times negative 1 times 3 is equals to negative 3. 1 times 2 times 9 is equals to 18. And now, let's subtract it to the right diagonal. 1 times 1 times 3 is equals to 3. 1 times negative 1 times 9 is equals to negative 9. 1 times 2 times 6 is equals to 12. Then, let's add it. 6 minus 3 plus 18 is equals to 21. 3 minus 9 plus 12 is equals to 6. Then, let's subtract. 21 minus 6 is equals to 15. And this is the error. Now, let's go on to the second set of matrix. Let's multiply the first diagonal. 2 times 9 times 1 is equals to 18. 1 times 6 times 1 is equals to 6. 1 times 3 times 1 is equals to negative 3. And let's subtract it to the right diagonal expansion, which is 1 times 3 times 1 is equals to 3. 2 times 6 times 1 is equals to 12. Then 1 times 9 times 1 is equals to 9. 18 plus 6 minus 3 is equals to 21. Negative 9 plus 12 plus 3 is equals to 6. The error is equals to 15. Now let's go to the last step. Let's multiply the first diagonal. 3 times 1 times negative 1 is equals to negative 3. 9 times 1 times 2 is equals to 18. 6 times 1 times 1 is equals to 6. Let's subtract it to the right diagonal. 9 times 1 times negative 1 is equals to negative 9. 3 times 1 times 3 is equals to 3. Then 6 times 1 times 2 is equals to 12. Then let's subtract it. Negative 3 plus 3 times 6 is equals to 21 minus 6. 21 minus 6 is equals to 15. And this is the error.
Now, we have another set of 3 by 3 matrix in finding the determinant. I will show you how to solve a 3 by 3 matrix using row determinant. This is the given element. First row, 9, 4, 5. Second, 8, 7, and 6. And last, 1, 2, and 8. To get the determinant, first, get the element of the first row. 9, 4, and 5. 5. Be sure to multiply it to the corresponding sign for that reference element. And the corresponding sign for 3 by 3 is positive, negative, positive. After that, get its cofactor by crossing out other elements in the row and column. In this process, we will be disregarding the row and column they are aligned with. In the first element, cross out the first row and the first column, leaving us 7, 2, 6, and 8. For the second element, cross out the first row and the second column, leaving us 8, 1, 6, and 8. And for the last element, cross out the first row and the last column, leaving us 8, 7, 1, and 2. Let's simplify. 9. 7 times 8 is equals to 56. Minus 2 times 6 is equals to 12. Minus 4. 8 times 8 is equals to 64. Minus 1 times 6 is equals to 6. Plus 5. 8 times 2 is equals to 16. Minus 1 times 7 is equals to 7. Simplify again. 9. 56 minus 12 is equals to 44. Minus 4. 64 minus 6 is equals to 58. Plus 5. 16 minus 7 is equals to 9. Multiply it. 9 times 44 equals 396. Minus 4 times 58 equals 232. Plus 5 times 9 equals 45. So, 396 minus 232 plus 45. The determinant is positive 209. As the discussant said a while ago, this is another set of matrix. But now I will be using column determinant. To find its determinant, first we will get the principal minor of this matrix, which is 9, 8, and 1. For us to be able to know the right sign, we will be using the checkerboard, which is positive, negative, positive, negative, positive, negative, positive. Since 9 is positive, so 9 here is positive. Then 8 times negative 1 is negative 8, and 1 times positive 1 is positive 1. Then we'll get the cofactors of each principal minor. For the cofactors of 9, which is 7, 6, 2, and 8. The cofactors of 8 is 4, 4, 5, 2, and 8. And the cofactors for 1 is 4, 5, 7, and 6. And then let's simplify it. 7 times 8 is 56, minus 2 times 6 is 12, minus 8 times 4 times 8 is 32, and 2 times 5 is 10, plus 1 times 4 times 6 is positive 24, minus 7 times 5 is 35. Then 56 minus 12 is positive 44, minus 8 times 32 minus 10 is positive 22, plus 1 times 24 minus 35 is negative 11. Then let's multiply. 9 times positive 44 is equals to 396, minus 8 times 22 is 176, plus 1 times negative 11 is negative 11. Then 396 minus 176 minus 11 is equals to 209. So the determinant of this matrix is 209.
We have here the 3 by 3 matrix. Finding the determinant, and we will use the crisscross process. Now, we have here the elements of 9, 4, 5, 8, 7, 6, 1, 2, 8. And we will get the first and second column outside the matrix. Then we will multiply these elements. 9, 4, 7, 8, 4 times 6 times 1, 5 times 8 times 2. Then, if we get all the product of these elements, we will add. The result is 504 plus 24 plus 8. The result is 608. Then, we will multiply again the elements to the left side. Now, we have the 4 times 8 times 8, 9 times 6 times 2, and 5 times 7 times 1. Now, we have the product of 256 plus 108 plus 35. Now, we have the 399. Now, if we get all the product of these, and we will add this result. Now, we will going to answer the determinant by subtracting 608 to 399. Now, we have the 608 minus 399 equals to 299. Then, this is our determinant.
We have here another set of example for a 3 by 3 matrix in finding the error. We may use row, column, or the crisscross. In this situation, we are going to use the row determinant. For an instance, we have here the set of matrix, which is 9, 4, 5, 8, 7, 6, 1, 2, and 8. Using the row determinant by interchanging the rows, we have here now the 9, 4, 5, 1, 2, 8, 8, 7, 6. Then, follow the instruction in determining the determinant that was discussed earlier. So, we have 9, 4, and 5 as the principal minors, and 2, 8, 7, 6, and so on as the cofactors. So, we have here 9 times 2 times 6 minus 8 times 7 minus 4 times 1 times 6 minus 8 times 8 plus 5 times 1 times 7 minus 8 times 2, which is equals to 9 times 12 minus 56 minus 4 times 6 minus 64 plus 5 times 7 minus 16, which is equals to 9 times negative 44 minus 4 times negative 58 plus 5 times negative 9, which is equals to negative 396 plus 232 minus 45, which is also equals to negative 209 as the error. To check, we also have here two patterns. So the second pattern is 1, 2, 8, 8, 7, 6, 9, 4, 5, which is the result from the interchanging from the given matrix. So we have here 1 times 7, 6, 4, 5 minus 2 times 8, 6, 9, 5 plus 8 times 8, 7, 9, 4, which is equals to 1 times 35 minus 24 minus 2 times 40 minus 54 plus 8 times 32 minus 63, which is equals to 1 times 11 minus 2 times negative 14 plus 8 times negative 31 which is equals to 11 plus 28 minus 243. The error is negative 209. To check, we also have the third pattern, which is 8, 7, 6, 9, 4, 5, 1, 2, 8. 8 times 4, 2, 5, 8 minus 7 times 9, 1, 5, 8 plus 6 times 9, 1, 4, 2, which is equals to 8 times 32 minus 10 minus 7 times 72 minus 5 plus 6 times 18 minus 4, which is equals to 8 times 22 minus 7 times 67 plus 6 times 14, which is equals to 176 minus 469 plus 84, which is equals to negative 209 as the error.
These are the steps in finding the error determinant of a 3 by 3 matrix. We interchange second row to the third row. That's why it became like this. Then, 9 times the determinant of 2, 8, 7, and 6. Negative 1 times the determinant of 4, 5, 7, and 6. 8 times the determinant of 4, 5, 2, and 8. Which is equals to 9 times the quantity of 2 multiplied by 6 minus 8 multiplied by 7. Negative 1 times the quantity of 4 multiplied by 6 minus 5 multiplied by 7. Plus 8 times the quantity of 4 multiplied by 8 minus 5 multiplied by 2. Equals to 9 multiplied by 12 minus 56 negative 1 multiplied by the quantity of 24 minus 35. Positive 8 multiplied by 32 minus 10. Which is equals to 9 times negative 44 negative 1 times negative 11. 8 times 22 is equals to negative 396 plus 11 plus 176. And we got negative 209 as the error. Same process as this. We interchange first row to the last row. That's why it became like this. Same process, then we got the answer of negative 209 as the error. Same process then like this. We just simply interchange first row to the second row. That's why it became like this, and we got the answer of negative 209 as the error.
I will discuss to you finding the error of a 3 by 3 matrix using crisscross. We will do the same given as we do on the previous report. 9, 4, 5, 8, 7, 6, 1, 2, 8. To determine the error of a 3 by 3 matrix, we will interchange either the row or column. Our first pattern is 9, 4, 5, 1, 2, 8, 8, 7, 6. As we notice, the position of the row 2 becomes row 3 and the row 3 becomes row 2. We will do the same process in solving the determinant of a 3 by 3 matrix using crisscross. We will add the diagonal product from the left hand. First, 9 times 2 times 6 is equal to 108. Plus, 4 times 8 times 8 is equal to 256. Plus, 5 times 1 times 7 is equal to 35. We will subtract it from the sum of the diagonal product from the right hand. So, first, 4 times 1 times 6 is equal to 24. 9 times 8 times 7 is equal to 504. Plus, 5 times 2 times 8 is equal to 80. We will add the diagonal product. 108 plus 256 plus 35 is equal to 399. Minus 80 plus 5, 104 plus 24 is equal to 608. We will subtract 399 from 608. The result is 209. Our second pattern is 1, 2, 8, 8, 7, 6, 9, 4, 5. we'll do the same process. 1 times 7 times 5 is equal to 35. Plus 2 times 6 times 9 is equal to 108. Plus 8 times 8 times 4 is equal to 256. Minus, as we do the same thing on the first. 2 times 8 times 5 is equal to 80. Plus 1 times 6 times 4 equals to 24. 8 plus 8 times 7 times 9 is equal to 504. The sum of this equation is 399. And the sum of this equation is 608. After that, we will subtract it. 399 minus 608 is equal to 209. Negative 209. Our third pattern is 8, 7, 6, 9, 4, 5, 1, 2, 8. 8 times 4 times 8 is equal to 256. 7 times 5 times 1 is equal to 35. Plus 6 times 9 times 2 is equal to 108. And 7 times 9 times 8 is equal to 504. 8 times 5 times 2 is equal to 80. 6 times 4 times 1 is equal to 24. We will subtract the sum of both sides. 399 minus 608 is equal to 209. Negative 209.